Hi folks, in this walkthrough video we're going to talk about a couple of new concepts. The main concept is dependency injection, which is a rather large area. We could talk about it for a while. It could be probably the subject of an entire Java class. But for us, we just want to get a little taste of what dependency injection is, in particular because it's part of the Spring framework. We're going to use the Spring framework coming up, starting in the next class period, to help us build MVC web applications, just like we did in Unit 2 using Python. Spring will allow us to do that using Java. Spring is a very large framework, and in addition to allowing people to build web applications, it includes an aspect called dependency injection. And so dependency injection turns out to be two things. One is it turns out to be really useful for a lot of reasons, aside from the fact that it's just part of using the Spring MVC framework, but it turns out to be also really difficult to understand at first. Dependency injection is a complicated concept. The first one, two, or even three times I saw it, I didn't really understand what was going on totally. So we just hope to give you a little taste of it here, just to give you some repeated exposure. And when you see it in Spring, you'll have a little better picture of an idea about what's going on when you're using dependency injection in your applications. The other thing we're going to talk about is a tool called Maven. And so Maven is a tool that will help pull in external libraries, external Java libraries from the internet into your projects within Eclipse. Okay, so let's go ahead and dive into this walkthrough. We're going to set up a little application and just demonstrate a few of the different capabilities of dependency injection and see how that works. So for this walkthrough, I would say don't feel like you need to follow along with me here. If you would like to, that's fine, but just kind of focus on paying attention to what I'm doing and what I'm building here and understanding the concepts that are going on. All right, so I'm going to build a new project here. So I'm going to go to my Project Explorer, right-click, and hit New. And in the past, we've just created Java projects. This time, though, I want to create a different type of project. So I'm going to go down to Other, and if you just search Maven, you'll see you get some different options here, and we're going to build a Maven project. All right. Now for this dialog, I need to just select a couple of options. In particular, I'm going to, for this particular project, I'm going to just create a simple Maven project. There are some different project templates you can select from if you don't check this box, but ours is going to be a pretty basic one. And this, I'm going to leave this the way it is as well. All right. So two pieces of information that Maven needs to create a project are what's called a group ID and an artifact ID. And these are kind of more important if you're publishing your project to the internet. If you wanted to create, say, an open source project that you wanted to allow other people to use, and you wanted to make that available to others through Maven, you would identify your project by group ID and artifact ID. So here, kind of what we choose these IDs to be is a little bit, it's not terribly important for this particular project, but we're going to go ahead and follow some best practices anyway. Group ID is often has something to do with the organization you're working with or coding for. So here we're just going to call ours org.launchcode. This kind of reverse URL is something that's pretty common in the Java world to identify projects and packages. And the artifact ID would be the kind of specific project within that organization that you're building. So in this particular instance, we're going to build a project that essentially kind of mimics behavior of like a home stereo system. So I'm going to call my project Sound System. Okay, and all this stuff is generally fine. If you're building a more complicated project, you might have to fill out some of these other fields. Okay, I hit Finish, and notice I have a new project over here on the left. If you go ahead and expand this arrow, notice that there's a lot more stuff in there than you would normally get if you created a plain Java project. In particular, you have several folders. If you were to go look at this on the file system, you would see a source folder and a test folder, source folder, and then within that, main and test, and within those, there are then Java and resources. And so in particular, we have this sort of built-in structure, and this is dictated by Maven. Maven needs to have a very particular project structure so it can properly manage its own resources. So when we create a Maven project, this sort of structure is going to be automatically created for us. And in general, or in particular, we're going to do most of our coding in the source main Java. This is where most of your source code is going to go. If you write unit tests, you should put those in the source test Java package. And then the resources folders are generally for static resources, things like templates or JavaScript files or HTML files or things like that. Let's see. We also have a file down here at the bottom. This is at the top level of our project. It's called a pom.xml. And so POM is an acronym, POM. It stands for Project Object Model. Let's just open this up. When you open it up in Eclipse, it tries to give you this helpful view, but if you go to the far right tab, see over here, there's this little tab system underneath the POM. You can actually see the raw file. This POM file is what is going to essentially configure our Maven project. So the situation we're dealing with now is we want to build a project that uses the Spring framework. Okay, we're going to use Spring's dependency injection tools in this project. In order to get those aren't installed by default. Those aren't just part of Java. So we need to somehow get those packages installed on our system so we can use Spring. And Maven is really best at managing that stuff for you. So the POM is the heart of a Maven project. It's what tells Maven what external dependencies your project has. So in this particular case, I just have a list of these external dependencies. So I'm just going to open those up and copy paste these different dependencies. And I'll provide a link to this POM file on the course page. So if you want to walk through this, you can just use the POM file that I provide. In general, if you wanted to say add a new library to your Java project, and you were using Maven, you could come in here and you could either add it through the dependencies tab here. Eclipse will let you add these things, and if you go through this process of adding things, then that will automatically create the POM file for you. Or if you really know what you're doing and want to do it manually, you can come in here and edit the POM file on your own. So this POM file is a special file type called XML. XML stands for Extensible Markup Language. It's not really important for us. You should just know it's a file format that's used a lot, especially in the Java world for configuring projects of various types. And if it looks sort of similar to HTML, that's not an accident. XML and HTML are closely related markup languages. Okay, so let's just kind of take a quick view of what's in our POM. So let me just note that we don't expect you to kind of master what a POM is or how to use it. We should all kind of get familiar with the concept that a POM file is where we specify the external dependencies of our project, and that Maven somehow pulls those in from this POM file. What's really happening is Maven goes out to the internet to a centralized server, and based on the information you provide here, for example, for this dependency, which is specified as org.springframework, and it has an artifact ID, it will look on its server for that particular Java project, and it'll suck it into our project here on our machine. Okay, so each one of these little dependency tag sets specifies a different Java project that we want to use. Okay, so here we have something within the Spring Framework project that we're gonna pull in called Spring Context. Here we have JUnit that's going to pull in the JUnit libraries for us. We have something in the Spring Framework project called Spring Test. And then we have something else down here, which is basically a project we're going to use as a one-off little tool in our unit tests that will allow us to kind of better test our application. So these are just different dependencies that our sound system project is going to have. And by configuring our project properly using this Maven POM file, we won't have to worry about where those come from. Maven will just know how to pull those in and how to properly build our project. Okay, so that's our POM file. Again, as we go forward, if you need to update or modify your POM file for a particular studio or problem set, we'll provide you with the information you need to do that and some very explicit instructions. Okay, so that's Maven. Let's go ahead and now that we have our Maven project set up and we have Spring that has been pulled into our project via Maven and the POM file, let's go ahead and start actually coding. All right, so first thing we're going to do is I'm going to go up to source main Java, and I'm going to create a couple of interfaces. All right, so I'm going to create a new interface called Media Player. All right, and it's going to have just a single method called play. Let me just say that's public. And so think of a media player as a CD player or an MP3 player or a DVD player, something like that. One of the primary behaviors of a media player like that is that it should be able to play media. And then I'll also create something that is going to represent an interface that's going to represent a type of media. So here, let's create a compact disc. Okay. And this interface itself should also have a play method as well. We should be able to play a compact disc. If you take a compact disc and put it into a CD player, you hit play on the CD player, that in turn spins up the compact disc, and it is able to then output some music or spoken word or whatever's on that media. So these interfaces are just going to be what we use to kind of stub out the behavior that our sound system should have. All right, so now we actually need some instances of each of these classes. I need something that implements each of these interfaces so that I can then use them. So let's go ahead and create a new class, and it's going to implement our compact disc interface. All right, so I just put it there. I'm going to name it Born to Run. I've been listening to Bruce Springsteen a lot lately, so we're going to make it Born to Run. So we've got this auto-generated class that already stubs out the interface method that we need to implement. So here for this, let me just add a couple of private fields. A string, it's called title. That's the title of this compact disc. And let's see, then an artist, and then play. Again, this is all just kind of mocking behavior. We don't actually have a real physical CD player, physical CD here. So we're just going to print something out, system.out.println, and I'm going to say and we're just going to print out a message. Okay, so if we were to run this, the message that would be printed out to the console would be playing Born to Run by Bruce Springsteen. All right, simple enough. So that is our CD, our compact disc implementation, and it's a specific CD, Born to Run. Now we need something to play that in. We actually need a compact disc player, so I'm going to go create another new class. I'm going to call this CD player, and it's going to implement the media player interface. Okay, and again, we get in this situation Eclipse creates a minimal class for us. It has a stubbed out play method that we need to implement. We have a CD player, and our CD player, in order to play something, it actually needs a CD, right? So let's go ahead and say that we have a compact disc as an instance property. Call it CD, we'll make it private. And then we will go ahead and say that the play method should just play the CD. All right, so simple enough. Okay, so let's see, what do we want to do next? So we have instances of our classes in each situation. We've kind of done the minimal amount of coding necessary. Let's go ahead and create some tests that we can work with, or at least one test that we can work with, and see what happens. So I'm going to create a new class, and I'm going to call this CD player test, and it's going to extend test case from the JUnit package. All right, does that look good? That looks good. All right, so in here, I'm going to create a new test. You remember I use the test annotation to configure my test, and it's going to be test CD player. All right, and here I just want to see that my CD player can actually play something. So in particular, I need a CD player instance, so I'm going to create a new one of those. It's a media player. All right. So one thing, notice I have this red underline. Let me take care of this really quick. I haven't imported the necessary stuff to get the test annotation to work, so let me go ahead and do that. Just a quick note there, I just did a quick keyboard shortcut. If you're on a Mac, I did Command-Shift-O, and that stands for Organize Imports. That'll kind of scan your Java file, look for any unused imports and get rid of them, or look for any imports that you need that aren't there and add them. So that's just a quick way to kind of get all your imports sorted out. All right, and so I'll use that keyboard shortcut quite a lot in this walkthrough video. All right, so I have a new CD player. Let's go ahead and say CD player.play. All right, and that should call the play method of our CD player. Let's see, where is it? Right here, which in turn plays the CD, and that CD should then print out a message. Okay, so in a unit test, how do we test that something was printed out to the console? Well, there's not really a specific easy way to do this. This is why I put one of those additional package dependencies, at the very bottom of our POM file. I added this dependency down here at the bottom for this guy, and this one is a useful tool for basically testing output that's written to the console. Okay, so we're going to go ahead and use this now. So I'm going to create a new instance property on my CD player test class, and let's see, I want public final system out rule. I'm going to call it log, and it's going to be a new system out rule. All right, so again, let me grab those imports. So look at, notice that this import pulled in the specific package and class that I just added. If I didn't have Maven set up to get to import that class into my project, Eclipse would be yelling at me right now. So if you're following along and your import isn't being found and you still have errors after adding this class to your file, it's probably because Maven isn't set up properly. All right, and then I'm going to add, let's see, I need to add an annotation to this too. I need to add the rule annotation. All right. Now, within this specific test, I can assert that these two things are equal. Let's see, I need to look up, I forget what the syntax is here, log.getLog. And then it needs to be equal to something else. In this case, it should be equal to the string put out by my CD class here. All right, and it looks like I've misspelled that. Assert equals. There we go. That looks good. So I'm using the log here. Log. This basically, think of this object as something that captures output that we write to the console. So here, when I do the CD player.play, that's going to force the CD, this CD instance of the compact disc class to print something to the console, but I want to kind of capture that so I can compare it, right? So think of this object log as capturing that output that goes to the console, and by using log.getLog, that will give me that most recent output that was written to the console and allow me to compare it to what I have written here. And also at the end of this, since I did a print line, that's going to print a new line character at the end of my message. So let me put a /n there too, because that's going to show up in the output as well. Okay, great. So now this is our test case. Let's see how this works. Let's go ahead and try to run it. So I'm going to do run as JUnit test, and it failed. Let's see why it failed. So it failed because there was an exception, and there was a null pointer exception, and that happened at line 8 of the CD player class. In particular, that CD property, that's an instance of compact disk, was null. All right, and you might have caught this earlier while I was creating this class. You might have said you never initialize that CD property, and you're correct. I never do, and that's why it's null when it runs. Now notice that Java never forces us to initialize a property here. It never makes us do something like, if we had a constructor that said, let me say public CD player. This is what a constructor for this class might look like. This is where we would typically do initialization. We would say this.cd equals new born to run. Okay, and notice that takes care of it. Let's go ahead and rerun our class now and just see that that works. And we did get a message output there. My JUnit didn't pass. That's probably, I have some small detail. Let's see, CD player test. Unclear why that's not working right now. I don't want to dig into that because it's kind of superfluous to the main point we're getting at, which is that within this CD player class, this is something that you would normally be doing, right? You would normally be creating a constructor for your class and initializing its instance properties within that constructor. Now, dependency injection, which we're about to see how this can change the way we do things. Dependency injection is meant to allow us to not have to do this. So basically, you'll learn as you continue writing Java that the more tightly coupled your classes are, the more you specifically refer to different types of classes within your the classes that you're writing, the less portable or the less flexible or modular your code is. And there are a lot of technical reasons why this is true that we're not going to really get into. But in particular, dependency injection is going to allow us to do away with this kind of behavior. It's going to allow us to, say, get rid of this constructor that initializes a specific CD without having to initialize that object explicitly, that property explicitly. We're going to instead set up some configurations so that this particular CD is automatically initialized. It's injected into our class for us. Okay, so that's the next step of what we're going to be doing right here. All right, so let's revisit. We just created a couple of classes. We tested them. Our test failed because we had a null pointer. This instance property was null, and that it's no surprise that that instance property is null because we never initialized it within the class. I now want to show you how you can use dependency injection so that Spring can create and inject that CD, an instance of the compact disk interface, into your class for you. Okay? So let's see. To do this, we need to kind of set up Spring within our project, and this is going to take a little bit of work. So just kind of follow along with me here. I'm going to create a new class here. Let's see, I'm going to call this CD player config. All right, and this class is a kind of a weird class. This is going to look kind of strange. The main purpose of this class is to basically configure Spring, to give Spring some information about our project so that Spring can then help us manage our objects. Okay, so I'm going to add the configuration annotation here. And notice that annotation comes from the Spring Framework packages, Spring Framework, org.springframework.context.annotation. So this annotation is part of Spring. It tells Spring, hey, this class contains some important information. And then I'm going to add a component scan annotation. And I'm going to tell component scan to scan the sound system package for us. Okay? So the whole purpose of this class, think of it as a configuration file. We want to tell Spring for two things. First, hey, we want you to manage this pieces of this project for us. All right. The second thing we want to tell Spring is, here's where you should look for special classes and special objects. All right. So in this case, we only have one package. We only have this sound system package. If we had multiple packages, we might want to put all of our Spring managed classes in a specific package so that we could specify those to Spring. So the things within this package that it's going to be looking for, Spring is going to be looking for certain things that are set up to be managed by the Spring dependency injection framework. So now we actually want to go add those the proper configuration stuff to those classes. We want to tell Spring which classes it should manage for us. In particular, I want it to manage this class, right? So the born to run, which is our specific implementation of a compact disk. I'm going to call this a component. All right, so component, this annotation, putting this annotation on the top of your class in a Spring project tells Spring that it should manage instances of this class for you, okay? And we'll see what manage means in a second. I'm going to then go over to my CD player, and I'm going to do a couple of things. I'm going to say that this is a component as well. I want Spring to manage this class for me too. And I also want it to do something else. I want it to auto-wire this particular instance property for me. There we go, auto-wired. So by adding this auto-wired annotation, the component annotation, let's step back a second. The component annotation tells Spring, hey, this is a class you should know about, and you should be able to manage for me as necessary. Auto-wired tells Spring, hey, while you're managing this class, go ahead and set up this property for me. Set up this instance property for me. So we don't need to initialize this property by creating a new object in a constructor. We can tell Spring about it, and Spring will initialize it for us. All right, how does that happen? Well, it looks for things that implement this interface that are also components. In particular, this guy, right? The born to run CD implements the compact interface. It's also a Spring managed class. So if Spring is scanning our project and we tell it to initialize this property for us, that is the one thing it's going to find. If we had other CDs that weren't components, it would not see them. The component tells Spring, here's a class that you should care about and you should manage. Okay, so by doing this, if we create a CD player in the correct kind of way, Spring will inject it with the born to run compact disk. We won't have to initialize that compact disk ourselves. All right, so let's go ahead and test that out. I need to come back over to my test case, and I need to do some stuff here to manage it. So in particular, here's how I was creating a CD player before, right? I was creating it using a constructor, using the new keyword and the CD player constructor. I don't want to do that anymore. Why don't I want to do that? I don't want to do that because I want Spring to manage it for me. So I want this to be an instance property. Let me make this private. And then I want Spring to manage it for me, so I'm going to say that this should be auto-wired. All right, so by adding that auto-wired annotation, this tells Spring that it should create this CD player object for me, so that then it will be available to my test case. All right, so again, we're getting rid of constructors here. In general, you'll come to learn over time that constructors are not always the best way to create your classes. All right, so a couple more things I need to do. Let's see, we need to then do some configuration on our test case so that it is a Spring test case. So in particular, I need to come up here and add a couple of annotations. So I need to say run with, and then Spring JUnit for class runner dot class. All right. And let me get all those imports. That looks good. And then I need to add one more, which is a context configuration. And that's going to need okay, so we need to tell Spring about our configuration class. All right. So this first annotation basically tells JUnit, hey, you should use the Spring JUnit class runner. We want this to be a Spring JUnit test case. The second annotation configures that Spring JUnit test case with a certain configuration. So this turns out to be pretty useful. Notice that this class right here, this was this weird one that we created that I told you was configuring our Spring project, All right. Turns out you can have multiple configurations, and you can use different configurations for different situations. So you could use one configuration for your production application and one configuration for testing. That turns out to be really useful. For instance, when you want to, say you had a web application that you were building and it talked to some other service, right? It talked to like a weather API or some external service. You wouldn't want to run your test cases against that actual other service, right? You would want to basically create a fake weather service and use that fake weather service when testing your application. So this is one of the other benefits of Spring, is that the dependency injection, along with this special method of configuration, allows you to use sort of different environments for different situations. You're going to generally want to test your application in a slightly different environment than where you would run your application in the real world. All right, so I think we're all good. Fingers crossed. Let's go ahead and try to run our test case again, and then we'll back up and, assuming this all goes well, we'll talk about what we just did in review. All right, I go to the JUnit tab, and sure enough, my test passed. All right, so great. What just happened, right? A lot. So your head is probably spinning right now. You have no really idea what's going on. For a lot of you, there's a lot of stuff we just talked about, a lot of new words. Let's talk about the essence of what we just learned. Let's talk about the core ideas that you should come away from this with. And let me also say that dependency injection is hard. Okay, the main reason we're introducing it to you is it's not really a beginner concept. It's an intermediate to advanced Java concept, but it's necessary to use Spring. We want you to be able to use Spring to create web applications. It's the most widely used Java framework for creating web applications. And to do that, you're going to need to know a little bit about dependency injection. All right, you're not going to need to be a master of it, and you certainly won't right away. Like I said, it's a difficult concept, but we don't want to just throw you off the deep end and have you be confused by what's going on when we do see dependency injection occurring within our Spring web applications. All right, so we understand that this is a difficult concept, that it's going to be confusing for a while. This is pretty much the simplest sort of situation in which we can present dependency injection for you. Okay, so let's back up and see what happened within this test case and walk through it and get a sense for exactly what was going on. All right, so I have one test case here. Let's look at our one test case. Our one test case is going to access this instance property, CD player. It's going to try to play it, and then it's going to test that the output of that that action matches what it's supposed to match. All right. Problem is, this CD player is never created. Previously, we had something like this: media player, CD player equals new CD player. Right? We had that previously. We took that out so that Spring could create our CD player for us. All right. So let me actually use some little diagramming here. Think of Spring as a big box that your classes sit inside of, or at least some of your classes. Okay, so this is called the Spring, pardon my handwriting, container. So every Spring application has a Spring container. That Spring container is where all the Spring managed stuff goes, right? All the Spring managed classes and objects go in that Spring container. All right, so we have, in particular, we have two Spring managed classes at least, right? We have born to run. I'm going to kind of abbreviate that because I'm out of space. And we also have a CD player. Okay, by adding the annotations, these component annotations, to those two classes, that basically put those two particular classes within the context of Spring. It allows Spring to be aware of them and to create instances of those classes for us. Okay. In particular, notice that in my test case here, I have an instance of CD player. All right. When I say that I want Spring to auto-wire that for me, that says, hey, Spring, go find something that's of type media player and that it's configured properly so that you can set it up for me here. All right. What Spring is then going to do, it's going to try to find a class that implements that interface, that implements the media player interface, and it's going to try to create it for us. All right. In this case, there is exactly one class within our project that does that. The CD player class is the one media player class within our project. It also happens to be a component. In other words, the Spring container knows about it, so that Spring can then create for us CD players. All right, so Spring will create an instance of CD player for us. All right, let's go look at what that means. All right, so there's no constructor here. How does it create the class? Well, it turns out that every class, recall that every class extends object. This is kind of redundant. All right, but every class extends the one big capital O object class. All right, that it turns out that class has a default constructor. All right, it has a constructor that Spring is happy to call. All right, so we don't need to provide a constructor in every situation for our classes. But nothing special is going to happen when Spring calls that default constructor, right? That default constructor could not possibly know how to set up this compact disk instance. How does that get set up? Again, Spring does it for us. It's auto-wired in for us. So think about this diagram. You have a CD player, and it has a CD property, right? Spring can then wire that up for you. It can then create a copy of Born to Run and make that instance property equal to that copy of that CD. All right, so Spring is going to do that for us. By adding the auto-wired annotation along with all these proper component annotations, Spring is going to scan everything properly, create those objects, and hook them up for us. All right, it seems like kind of magical. All this stuff is just happening, even though we're not doing it. But that's the power of Spring. That's the kind of the black magic of dependency injection. All right. Now, if we didn't have this CD set up to be a component, Spring wouldn't be able to wire that up properly as well. So if you were to go back over here to this diagram, if I didn't have this guy, if Spring didn't know about him, right? Say that Born to Run was over here outside of the Spring container. Spring would have no way of knowing which object it should create to instantiate the CD property within my CD player. Okay, so it's only by making Born to Run a Spring managed class, in other words, a component, that Spring can then understand where it is, find it, create an instance of it, and hook it up to this instance property for us. Okay. And so that's essentially what's happening. Spring is aware of these objects. It knows how to create them for us. And as long as we set up things properly, it will handle a lot of behaviors for us. Now, let me make one more comment before we kind of end this lesson, which is that I mentioned a couple of times that when I set a property to auto-wired, that property, what that tells Spring to do is to go look for something that implements this interface, right? So, and actually, I probably should have called that. No, compact disk is right. That is the interface. So it'll look for something that implements that interface. What if we had two CDs, right? Let's go ahead and just kind of demonstrate that. Let me make a new class. I'm gonna call this Sergeant Peppers. This should implement the compact disk interface. And all right, I'm not going to really do anything with this here. I just want to illustrate what's going on here. So what if we had two classes that were both CDs? How would Spring know which one to create to instantiate the CD property within my CD player? Well, in this case, the way it is now, one of them is a component and the other one is not. So Spring doesn't even know about this. So in this case, it's not going to be confusing to Spring at all. It's going to say, hey, I know of only one compact disk. I'm aware of only one compact disk. It's born to run. Okay? So that's the only one it could possibly create and use to initialize this property. That's the only one it's going to do. If I then went over here and made this a component as well, then we'd have some problems. So if I did this, and if I tried to run my code, let's go ahead and do this. And we indeed get an exception. What is that exception? It's pretty convoluted down here. I'm not going to go. There's a lot of stuff here, but basically, let's see if the console has anything illuminating. It says failed to load application context. Error creating bean with name CD player, unsatisfied dependency, nested exception. One more down. So here we go. So here, Spring is trying to create a single compact disk to wire into this property, right? But it says that it can't set up our compact disk for us because it expected to find only one, but instead it found two. It found Born to Run and it found Sgt. Pepper's. It couldn't decide which one to use, but there were two. It was ambiguous, so it threw an exception. Okay, if I take this off, if I take that annotation off and try to run my test case again, Spring really shouldn't have any problems at all. All right, it doesn't. So even though in this case I have two compact disks, Spring doesn't know about this one. So there are some details about setting up Spring applications that you'll kind of stub your toe against from time to time, including things like that. But Spring tries to use some basic predictable behaviors to manage your application for you. And even though right now it's not obvious necessarily why that's the case, you'll learn as you become a more mature developer that this turns out to be extremely useful. And as we go along and learn about Spring MVC and start building web applications with Spring MVC, we'll use these annotations and others, and we'll kind of explain to you how dependency injection is working in those situations. Okay, so main takeaway from here is we created a Maven project that uses Spring to manage our objects. And in particular, we don't have any constructors in any of our files, no constructors anywhere. Yet, we're still able to have code where certain objects are created and run despite the lack of constructors and despite the lack of things like the use of the keyword new. And so Spring was doing all of that work in the background for us. All right, so that's your introduction to dependency injection, and we'll see it more in action as we go on.